Welcome to Intro to SQL for Reporting, Part 1. Who is this video aimed at? For people who are changing jobs, or the job is changing. Let's say you got your resume put together, you're looking at a job, and you say, well, I could do that except for SQL. I don't know SQL, I don't know SQL. What is this SQL thing? And is it pronounced SQL or SQL? And either way, some people will mishmash. I'll interchange SQL and SQL anytime. So basically, it's for people who need to get data out of a database in the form of probably a report or a data extract. So you say your boss comes to you and says, "Oh, we need to send data to this other company because we're going to be doing a web presence with them, and they need to know our inventory levels. And so here's you need to do this." And so now you got to go, "Whoa, what does that mean?" And so what it means is you've got to learn to write a query. So. And the same thing is, maybe the job you're running or whatever, you have to provide reports, and the reports come out of a database. And this is how you get data out of a database. Hadn't always been that way. So what's a database? A database is just a collection of interrelated files. Originally, databases were just a company or whatever person's list of flat files they had. And flat files were just files that you had rows and records is what they call them. So a file is made up of records, and then the records, each of the records had fields, and then as a programmer you'd have to go through and write code that would know the exact layout of the file, so it knew that everything was in this order and so forth, and then it would have to loop through all the files or all the records, and then the files were such a way that you'd have to read through. If you had 100,000 records in a file, you'd have to, and you needed the 84,103rd one, you'd have to read through or loop through 84,102 records before you got to that. But then they came up with this idea called index files. And index files are files that have a key value that allows the system, the computer, to jump directly to or really close to that record, so that the seek time and processing time is much faster on a file, and allows for data interaction in a more random order, so you don't necessarily have to access it in what's called a sequential, or 1, 2, 3 in every record. You could jump directly to it. So with the index files, they came up with this idea called a hierarchical database, where they took the index files and linked them together. And so a hierarchical database, think of it as like a family tree. And a family tree, you've got grandparents, you've got parents, you've got children, and children can have parents. So grandparents are the parents of their children, which are parents of their children. So, but a programmer would have to come in and write special code and know the exact layout of everything here. So let's say you have a customer, and the customer, you get to the customer level, then you'd have to write, that the customer can have an address, and this might be their default address. So you'd grab the address, but you keep that in mind that you might not be using that because you're going to go to the order, and you say, oh, wait a minute, they're not using the default address, they're using they have a separate ship-to address, so you have to know that you have to go and get this ship-to address, so you have to in each point along here you have to traverse, so you have to say, oh, I have to go to the child, and then I have to go to the child, and then you say, okay, I got the address, now I have to go get its siblings, and the siblings are the lines, and the lines is where all the detail is. And so as a programmer, you'd have to have a programmer, a special code that would go through and loop through and know exactly the layout. And so anytime you needed a report, you'd have to have a programmer do it. Then along came the concept of a relational database. Now, a relational database came about from the idea in 1970 by E.F. Codd, I think, Codd, from IBM. And the idea is a collection of related tables, and the tables are made up of you've got rows like records in a file, but you have columns. So here we have two tables, customer and orders, and you'll see that the customer has the name, user IDs, but there's a key value here. This is the customer ID. That's called a primary key because it uniquely identifies a row in this table. And orders, it has an order ID, and it uniquely identifies a row in the table. Usually these IDs are just sequential numbers. However, there's also a customer ID in the orders table, and this relates back to customer table and is considered what's called, since it's a primary key in another table, it's called a foreign key in this table. So if you have a foreign key, you know that's related to a customer. We have our tables now. It's in a relational database, but how do we get the data out of it? Do we have to write programs and stuff? No, that's where SQL comes in. Structured query language. Donald Chamberlain and Raymond Boyce decided that they studied this relational database model and decided to take on the challenge of writing a language which would allow you to pull data out of it. So SQL was originally called SEQL or SQL, and it was a structured English query language, but it was changed to SQL because the SQL was a trademark. So that's why you'll hear SQL pronounced SQL or SQL. So it could be confusing at times if you're in an environment that actually uses SQL, the SEQL, but I'm not even sure if that's even that prevalent anymore. We now need a way to get data out of the database. We're going to be sending a text file into the database engine and then get a results set out, usually called a record set or result set. Now the text that we're going to be sending, also known as the query, which will be written in SQL, can be written in Notepad if you want it to. But a lot of times people will be using some type of querying management, some kind of studio. Microsoft has their SQL Management Studio, I think, and there's third-party products called, one's called the Aqua Data Studio. So you could use various ways. You could even go to the command line and just type a query in if you have access to the database engine over a shell or some type of network connection. So the query is written in text, it's passed to the engine goes ahead and validates that the query is structured properly, runs the query, and returns the result set. It's up to you, but this couldn't be a hands-on tutorial, so if you want to follow along and write the queries with it, you're going to need probably the same tool I'm using, and that tool is DB Browser for SQLite. Now SQLite is a standalone program that can handle the SQL and running queries, but it does not have its own interface for writing the queries and those things. So we want some way to access the database that we're going to be using. Go to your address bar in your browser and you can type SQLite browser or just DB browser for SQLite, and that will take you to their site. Just click the download link at the top of the page, and it's available for Windows, Mac, Linux, FreeBSD. To download DB browser, just DB browser for SQLite. This one again is the one I've gone to, so go ahead and SQLitebrowser.org. Here you can see a little information about it. You can read up on that if you want. Go ahead and click the download tab, and then whatever version you're running, you want to run, whether it's Windows. They do have a portable app. This one is, you could put on a thumb drive, or basically it's a folder where you could, if you want to get rid of it, just delete it. You don't have to install it. or just run one of the installers for your version. This Mac and Linux. That's how to get DB browser. We're going to be also using a sample database. This database is the Chinook database. You can also get this for free. You could either do a search on Chinook database, and you're going to be looking for this GitHub LaRocca Chinook database. So if you do the search, you find that link, verify it's LaRocca, click this link where it's Chinook database, then click the data sources, then click the link on the next page, make sure it's the .SQL, and then go ahead on the next page, click the download. So let's go ahead and do that Chinook database. So, okay, obviously I've been here before, so we go ahead and open that, and we get the page that's Chinook database. Now we want to click on the Chinook database, updating documentation, and click that. Then we're going to look for data sources, click that, and then we're going to scroll down until we get to the SQLite. So we're going to click that one, and now we finally get to the page where you're going to actually download it. So go ahead, and it's a 1 megabyte. So go ahead and download that, and go ahead and save the file. Know where you saved it, because we're going to be accessing it later. So if it's in your downloads folder, go ahead and make note that it's in your downloads. If you put it somewhere else, make note of where you put it. When you open DB browser, you should get something like this, and at this point there's nothing happening because we didn't point to the database yet. So we're going to go ahead and open the database. Now I happen to have mine in SQL. So you're going to be looking for your Chinook SQLite.SQLite, and go ahead and click open, and we have a list of the database structure. There's a few tabs here. You can browse data, so here you can change your table names and look at the data directly. Parameters, not going to mess with those. And then this is where we're actually going to be spending most of our time, is in the execute SQL or SQL. So let's take a look at the database. You've got a list of the tables and the indices, which is a list of indices. So you can see here IPK is an index. This is the naming convention for a primary key, and the primary key is what uniquely identifies a value in a table, or a row in a table. And the foreign key is a primary key in a different table, which allows you to link tables together, and we'll get into that shortly. But first we're going to take a look at the actual database itself. It's the collection of tables. So we have album, artist, customer, employee, genre, invoice, invoice line, media type, playlist, and playlist track, and then track. We can tell from this that some of these things are obviously related, like invoice line and invoice, playlist track and playlist, artist and album. If you click on the little arrow next to it, you can get a list of the actual column names. So the album just has an ID, title, and a foreign key, the artist ID. Artist just has the artist name, artist ID. The customer, again, listed out. We have customer ID and so forth. I'm not going to cover all these, but you can see that there are, like if we go to invoice, we can see that the customer ID is in an invoice, so that we know, oh, we can join those tables. Same thing with track. So you got track ID, playlist. Oh, look, track ID's in the playlist. Track. Got confused with playlist. Okay, enough messing around with that part. Let's get on to what we really want to do. We want to write SQL. So the first statement, and since we're going to be working on it, it's the select statement. And the select statement allows you to select columns, values out of columns. So the basic select statement starts with select, and then you have to specify something. So in this case, we'll just specify 1, 2, 3. And then we'll highlight it and press this play button, execute. You can see where it highlights the shortcut keys, but I'll try to keep using this button. And so you can see we just selected 1, 2, 3, 1, 2, 3. Okay, cool. Now what we can do, and I'll keep doing, is just add another select statement. So we'll go ahead and select hello and see what we get. Well, we get no such column. You see it's got the squiggly lines. You see, well, that's because hello is a string, but it doesn't have quotes on it. So it's not technically a string. The system thinks this is a column name. So to make it a string, we put quotes around it. We can rerun it. And now we select hello. One of the things you have to be concerned about is when you select multiple columns, there's a keyword called as. So we could select hello as, and then we'll call this world, and we'll go ahead and run that, and we'll see that now the column name is called world. So we're writing SQL, and some SQL is limited and specific to the database engine you're using. So Microsoft SQL and Oracle and Postgres and MySQL, and there's other databases out there, relational databases, may do things differently. And so here, if you happen to omit the as in SQLite and run that, you'll see that without the as, it just said, oh, you must want world. But what if we want it actually world? So we say, okay, now we're going to go ahead and put world. It's still calling it world because it doesn't have a comma. Now if we add the comma there, we can now select world as separate from hello. So the comma is very important to separate your columns. And so let's do a special select asterisk, and you can go from the SQLite, and this is master. This is a default table in SQLite, and a lot of systems are going to have a similar table to this, where you can then query information about the database itself. So here we have a list of types which lists out our tables and our indexes, and you can see the column names, or the name of it, the TBL name, which I'm not sure what that is, and the actual SQL that could be run to create that table. We won't get into creating and stuff. We're just going to mainly key on select statements, getting data out of it. So now let's actually do something with the data. So we did the select asterisk. What does that mean? That is a placeholder or a wildcard value that allows you to select all the columns from a table. So we know one of the tables is called artist. See, this is a nice little completion feature there. So we'll go ahead and select that and select everything from artist. So now we have the artist ID and the name. So as a shorthand, exploring a database, looking at different things and seeing how things relate, you may want to use the asterisk. However, I do recommend not using this when you write a query for production, or you're running this for real, and data extraction and so forth, because tables can be modified through the use of what's called an alter. And so if there's additional columns that are added, you could inadvertently add data to a report that's not expecting it and cause the report to fail, or data extract and send out data you really didn't mean to send out. So always, if you can, specify your columns. So here we know we can do that by doing artist and then ID and then comma name, and I don't like that as that, so we can call it as artist name. And we can't put spaces in here because remember, it's going to think it's another column. So I will either you do this where you capitalize things like that, or put in what's called an underscore in between them. So when you run your query, you now have your artist ID and artist name. By taking something that's kind of generic without knowing what it is, if you were to once we get into joining tables, if you were to just use name, what name are you talking about? So we'll look at that later. Let's go ahead and do what's a way. So you can see down here there's 275 rows. There's also a way you can find out how many rows there are by doing a select count. Here you can always use the asterisk because this is just going to count the rows, and we can say as artist count, and then from we start typing, then you can hit tab and then run it, and now we have a number. It's from a query. That's the actual number of artists. So when you get and you're looking at a table, this select asterisk again is going to be a way for you to let's look at the customer. You're going to look at the tables and just explore it. So we're going to go ahead and run that. We got 59 customers. Select allows you to select your columns. So you can select your columns in any order that you want. So in this case, we're going to select last name first. Name, comma, first name, from customer. Now from, it just lists the column or the table that you want to select your columns from. And so we get a list of the last name and only the first name of the table. Sometimes you're going to be accessing a table that has a lot of rows in it, and you're not going to necessarily want to see all the rows because there's just too many, but you want to see some of them. So we're going to go ahead and use the playlist track, and we're just going to select a count from that and see that there are 8,700 rows in this table, and we probably don't want to see them all. So you can do a thing called limiting. This is where it's going to be a little different and depending upon the database you're using, but for SQLite we're just going to select everything. We'll use invoice. I know that's got more than 10, but we're going to just limit 10. And so what this will do is it will, oh, forgot my from. That's your syntax check. So I'm going to go ahead and run that, and now we have just 10 rows. And so other database may do select and then top 10 and then your columns from the table. Other systems may be select your columns from the table, but then you have to fetch first 10 rows only. Oracle, just whatever the row num. There's it has a special value called row num, which is, I believe, all caps, row num, and you can set that, instead of equal 10. So that would get 10 rows. Oops. So we have a way of getting our columns. We can limit our rows, but let's say we want specific rows. So that's where the where clause comes in. Where. You can check a column, so you can list out a column, and you can check it against a value that you provide, where it's can be equal to. So this is equal to. It can be greater than or equal to. So we can do like greater than or equal to. You can say just greater than. And the same thing with the less than or equal to or just less than. And then ones that you can get to that are of interest could be specified this way or this way, and that's not equal. So you can use either this value or this one. Depends on the system. Some of them will accept both. So to do that, we're going to go ahead and run our select. I'm going to select everything. And now we're going to change up how we're going to format our queries. I'm going to go from, and we're going to use customer. We're going to add our where. I'm going to say first name equal Robert. Let's go ahead and run that query. And you'll see you've got a customer with the name Robert. Looks like there's only one name Robert. So we don't have to worry about any other people that are even like Robert. Well, you can. And that's there's a special thing called the like with wildcards. So we can go select everything from customer. Oops. Where first name like, that's a special keyword, and Rob, and then we'll use the percent as a wildcard. Now the percent says go ahead and match it on every letter, any number of letters following this. So this takes the place as a wildcard of any number of characters. We'll go ahead and run that, and we'll see, oh, there's a Roberto. Cool. Another, I'm just going to copy this real quick because I don't have to type it all again. There's another wildcard, which is an underscore. So we're going to go ahead and we'll go ahead and run that and see what happens. Nothing. Well, let's go ahead and say 1, 2, 3, 4. Oh, one too many. Well, if we run 4 underscores, 4. No, it should be 3 underscores. 1, 2, 3. Yeah. So we got 3. We can run that. We see, oh, Robert. So an underscore takes the place of 1 character. So if you know there's a specific number of characters you want to limit, you can do that. There's also should have just copied it in. And now we'll look at the last name. and you can use the wildcards in any place. So here we're going to do %EE, %, and this allows us to, anywhere in the last name that 2 E's appear, we're going to go ahead and get those records. So there's 2 records, Peters and Parikh, I guess. So yeah, any number of characters before, any number of characters ever. So it appears anywhere in the thing. Now, what we can also do with the where clause is use values called and, or, and not. So if we select, again, our favorite table is becoming customer, from customer, where first name equals John, and last name equal Gordon. Oops. This name, first name. Okay, there we go. So we have the one record. I could have just probably done John, but anyway, I just want to show you can do and. Let's do this and duplicate that query, but we're going to use first name again and put like, and we'll do our our % again. So we're doing that wildcard, and so this should get us or anybody named John. And then we're going to do or, because the and won't work because nobody's named John and Rob at the same time. So we're going to do or, and we select that. Now we get our Robert, Roberto, and John. The not, you can also say and not. So we're going to say and not first name like Rob. So what's this going to get? It should get everyone except, yeah. So it just gets John because it's not. Now if we say, now if you accidentally use or with a not, you get something interesting. We get a whole 57 rows. So his first name is equal to John, or, all right, we want it not. Oh, we did do that. Never mind. Okay, so what's happened now? See, this is one of those things with nots. You have to be very careful. Usually, I'm not saying always, but usually you want to restrict that when you use a not to include an and. Otherwise, an or can get you into a little bit of trouble, and you can wind up with data that you were not expecting. So let's, again, now start working with actual column names. So we're going to select the email, customer ID from customer, where the customer ID equal 8 or customer ID equal 23 or customer ID equal 45 or customer ID equal 55 or customer ID equal 56. Woof. That was a lot of typing for that. So we can get a whole bunch of records specifying each value. And the reason I did it this way is to show you something called the in command or statement. So we're going to basically say, okay, we're going to grab this much and paste that. Instead of setting equals and using ors, we can list it out and say in. So with a customer ID, and since it's numeric, we'll have a list of the values and 56. And we're going to run this query, and hopefully it looks the same, because it is the same. Except there's a lot less typing, because if you're going to do an or on the same column, you can probably get away with an in. Now you can also do this on text fields just by specifying quotes around your values. Remember, numbers themselves do not need quotes, but strings do. Okay, so let's talk about nulls. Null. Null is a special ID. It's not an empty string or a value in of itself. It is just a concept that there's no data, but it's not treated as a empty string or a zero. So if we select count from customer where state equal an empty string, would help if I put my count what. You can actually put in a value here, so we could just say customer ID. So you don't have to use an asterisk. Just generally use an asterisk because it just represents the row. And so we get 0. And we're going to write another version of this, but instead we're going to say it's greater than, and run that, and we get 30 now. Okay. We're going to write this again. We're straight, and we're going to use the concept null. So now we can find the ones that are empty, but not empty strings. And that's where I want to specify. So now we have 29. And we know we have 30 greater than plus the 29 null. That gives us our 59 customers. So now we've accounted for all our customers. All right. At this point, I have an exercise for you if you want to do it. So if you've downloaded the database and you have DB browser or some type of way of accessing the database. So the question exercise is try to find out who is the sales manager. And when you after you figure that out, who are all the people in the IT department? So I'm work through this, and then when we come back, I'll go over who is the sales manager and who is in the IT department. This is just to see if you're, get an idea and see how you can work this through. So go ahead and pause now, and we'll see you back. Okay, if you've paused and tried it out, if not, I'm going to go ahead and show you what I did. So we're going to select answers from employee, where title equal, sales manager. Go ahead and run that, and we can see it's Nancy Edwards, because sales managers would be found in the employee table. And again, IT department, we're looking at the employee table again, so we're going to select employee, where again the title is, I think, well, we can just do like IT, and then that. So we'll say select all the employees where their title begins with IT. So we see there's 3. And there's Michael Mitchell, Robert King, and Laura Callahan. Which brings us to the next statement. Let's get back to doing another select. We're going to select, and we're going to do what's called an order by. So the order by shows up after the where clause. So, and this is going to allow us to return the data in column-specific order. So we're going to select first name, comma, last name, comma, country, comma, state, comma, city. Oop. And we're going to do from customer, order by country, and we're going to specify descending. The state is going to be, we can specify ascending, but ascending is generally the default. It depends on how the, I think some databases can be overridden to change the sort order, so that might be something you'd have to check specifically with your database. And we'll do city ascending. So the ASC is ascending and DSC is descending. So we should get this by country going ascending, and state and city by ascending. So we'll group them. We'll see now the data ordered by country, and then state, and then the ascending order for the and again, you can change however the order in which you do that by. Next thing we're going to move on to are called aggregates. Aggregates are made up of sum, AVG, which is average, there's max, it's maximum, and then min, which is minimum, and then one we've already covered called count. There may be other aggregates added to the database, but these are usually found in all the SQL databases or relational databases. Works by just like the count worked. So we're going to select a minimum, and we're going to select a column name. So invoice date, and we're going to say this is oldest date. So we're going to find the oldest and newest dates in our invoice table. So go max, and go invoice date as newest date from invoice. Now, if you notice, I've been, when I have specified my columns, and I drop my from clause to the next line. It's just the way I do things, but most people do that. They'll put the from on a separate, from, where, and so forth, so you can get a better idea of what's running. So oh, this is coming from this table, so you don't have to, because if you just put everything on one line, you'd have to be scrolling, and it makes readability a lot harder. So now when we run that, we have our oldest date and our newest date, because it goes and gets the minimum date and the maximum date. So we know our database invoice table spans from 2009 1/1 January to 2013 December. So now with the aggregates comes another concept called group by, and there's also group by having. Group by, what happens is if you have to select multiple columns and one of the columns is not going to be aggregated, so it's not summed, it's not averaged, like a text field. It's hard to average a text field. You need a way of specifying how to group them together, so it knows, oh, all these things need to go together. So we're going to go ahead and select a country, and then we're going to count up country, and we're going to call it as num of customers from customer, and then we're going to group by, and we're going to group it by country. Now if you're ever wondering what you need to group by, and if you get errors and stuff, you probably didn't specify one of the columns. In this case, we just have one of the extra columns. But if you had like 10 columns and then one count value or something like that, then you need to have those in your group by so that the system knows how to handle that. And this is where having num of customers greater than 1. Now, I also rename my count so I can reference it in my having. You don't have to rename your aggregates, but I do, because otherwise that way I have a definitive name I can reference in my having. So go ahead and run that, and you can see that Brazil, we had 5 customers. Ooh, USA has 13. So most of the and then you can order by num of customers, and now we know that the top, and then because we want to see who are our top, we can go ahead and sending and run that, and now we know our top. Let's talk about another statement. That's the between. We're going to use dates. Now each SQL engine will have its own way of handling dates. Now dates are a special form of a string. And I say that because, let's say your date is year, well, most dates are year dash month dash dd, and then there's like hour, minute, and seconds. Of course, this might be mm. It depends, because months and minutes, so it could be this way or this could be lowercase. But anyway, so this is 4-digit year, 2-digit month, 2-digit day, 2-digit hour, 2-digit minute, 2-digit seconds. Now a lot of time, and because of this format, you have what some people refer to as the 24-hour format. So it goes noon to 1300 to 1400 hours, 1500, 16, so forth. Now, there are ways of specifying things. The system can have additional functions that are built specifically for that version of SQL that can change your dates from this format to a format that you can, specify the PM and AM on. So built into most of them is going to be a date function. So let's go ahead and select date. Oops. And we will select when. We will select now. Oops. Now. This will give us a date. So it's May 4th, 2020 that I'm recording this on. Now with the date functions, you can usually modify this. So we're going to go ahead and select the date and put now. whoops, and then we're going to do, and SQLite has a modifier, but most of the languages, SQL engines are going to have ways of doing this. It might be slightly different. In this case, we're going to add 1 month. Oop, need to end that. And then, so now we should go out 1 month, and that's the 4th. Now you could do days and weeks and stuff like that, so whatever your requirement is. But again, that's probably something you're going to have to look up specifically for your database that you're working with, the version. And it's best to use date functions like this as opposed to adding 30 days, because obviously months have different values, and then you also run into leap years. So let the function do that math for you. And so we start off with between, and we're going to use the date. So let's go ahead and select the date. Now we're going to select everything from invoice, where invoice date between, and now we can specify our date. And remember, dates are strings because they have these dashes in them and so forth. So in this instance, we're going to specify out 2010 -01 -01, and we have to specify the hours. And I'm just going to copy this again and reformat it that way. Typing. So we're going to look for the whole year. So 12, 31. And if we run that, we get 83 rows, and so these are all the orders in 1 year, specifying that. Another way to do it is to use the date command, because then we can use a little more acceptable format than having empty time values in. So we can do select from, you know what, let's just do this. Grab that, paste that, between, and now we can specify the date and date. So using the date command, it's going to take part of the date and just date time field and use that. So let's go ahead and move that down. And run that. And so we get the same results, but again, using the date function, it helps us. Now another thing you can do is, like I said, part of the date, and again, this is going to be specific to the database system you're going to be using. Now you're not, but this is specific to SQLite. So we're going to select everything from the invoice, where, and this has a special thing called a string format time. So it's going to say, okay, I'm going to take this value and I'm going to format it, and this is a special thing, so we can specify the year, and then we say take the invoice date, and where that is equal to 2013. So instead of doing a date range like that, we can just say just grab everything with the same year. and get 0 because I remember it's a string number. So we run that and we get 80 rows for 2013. When you're done, you can come up here in this little button here and click the save and then pick a name for your stuff. So in this case, we'll just call it SQL.txt and save a file. And just remember where you put it, and then you can use this Open SQL file button to go ahead and open it again. Alternatively, you can Control A or select everything and then just copy and then paste it into a text document or a Word document or anything you want. Document that will that you'll know where it is and can save. So that's how to save your files from here if you want. We got this part, and we didn't even cover the relational part of the relational database. So the next part, we'll start off with joins, where we'll actually do the relational part. Until you do that, what I do recommend is going through the database and running your own queries, writing your own queries, and seeing, oh, if I do this, what happens? If I do that, what happens? It's one of the ways to really get to know how to write your own SQL statements, is to just start writing them. Have some fun with it if you can. So until next time, keep querying.